All right, so just remember when we do use a substitution, and I'll do it once so that we've got it. So tan x on 2, when we differentiate, we get dt equals x squared x on 2, and we've got a half dx. So if I multiply both sides by 2 and use 1 plus tan squared, so this identity, the Pythagorean identity here, that is the same as 1 plus t squared. So I've got 2 on 1 plus t squared dt, equals dx. So just remember that. So what I like to do is, when I'm doing something like this, I'm definitely going to change the limits here. So if I put the limits, the x limits in here, so I get tan of 0 on 2, which is still tan 0, which is still 0. If I put pi on 2 in there, I get a pi on 4. Tan pi on 4 is 1. So 0 to 1, and the same for b as well. And then just remember this. I know that I'm going to sub in for dx the 2 dt on 1 plus t squared. And I know that the bottom, everything has, so the cos, if I sub in, it's 1 minus t squared on 1 plus t squared. So it also has 1 plus t squared. So I know that I'm going to multiply top and bottom by 1 plus t squared to get rid of the kind of double denominators. So what I like to do for a bit of a shortcut is just sub the 2 dt in, and kind of, I've already times that top by 1 plus t squared then. So I need to times the bottom by 1 plus t squared. So this becomes 3 plus 3t squared. And 5, think of cos as 1 minus t squared on 1 plus t squared. So I'm going to divide that, times that, or by 1 plus t squared. So it just leaves it like that. All right, so when I simplify that, hope you followed that. I'm going to get the 2 dt, no problem. When I simplify the bottom, you can see I'm going to get 3t squared minus 5t squared, so negative 2t squared, and a 3 plus 5, so I'm going to get an 8. So if I put, I could divide through by minus 2, both top and bottom by minus 2. Or I'm pulling out, actually I'll pull out the minus and I will divide both top and bottom by 2. So I'm just going to get dt on t squared minus 4. Now, t squared minus 4, so let me rub this section out. So we've got partial fractions, difference of two squares. So think about it, I've got t minus 2, t plus 2. All right, so I know that's going to be a on t minus 2 and b on t plus 2. All right, so we need to figure that out. So again, you can just do the cover-up method here. So if I cover up the t minus 2 and sub in 2, I get 1 on 4. For b, if I cover up the t plus 2 and I'm subbing in t equals minus 2, I get negative a quarter. So straight away you can see that they've both got a quarter in them. So what I can do is pull out the 1/4 here. The a is, so then it becomes, and I've got, what did, right, yes. So just to make it easier, at the moment it's got negative, and that just might confuse things. So what I could do is just change my limits to 1 to 0, and then I can not worry that I've used that negative up. So let me try again. So here's a, so a is a quarter, so I will end up with dt on t minus 2, and b is negative a quarter, so negative a quarter, and that would be dt on t plus 2. Oops. All right, so moving that up a little bit. All right, so you can see they're both going to have a quarter out the front, then they're both just logs. T minus 2 between 1 and 0. 1 and 0, don't make that mistake. Minus a quarter log t plus 2 between 1 and 0 there. So they've both got a quarter. This will be a quarter log. Now I put 0 and I get a absolute value of minus 2. So I get a log 2, and then I'm going to get a log 1. So log 2's there, minus a quarter. Log, again I'm going to get a log 2, and then minus a log 3. So that's the same as log 2 on 3. All right, they've both got a quarter in them. So if I put a quarter there, then I've got log 2 divided by 2/3. So that'll just be 3. All right, so that's our answer for the first one. If I just move over here to the second one, in the same way, I'm going to, whoops, cancel that. I'm going to just make some room for us. So in the same way here, I'm going to do that substitution with the t. So it's now going from 0 to 1. I've got 2 to t on top. So cos is 1 minus t squared on 1 plus t squared, but I've times by 1 plus t squared. Sine is 2t on top. It's got 1 plus t squared on the bottom. So I'm just doing minus 2 times 2t, which is minus 4t. And then I've got 3 lots of, and remember, I've times by 1 plus t squared. So 3t squared. All right, so that just makes it easy if you can do that quickly. If I put that 2 out the front, what do I have left? So 0 to 1, I have a to t. If I collect my t squareds, I've got 3, take away 1, so I've got 2t squareds. And then I've got negative 4t, and 3 plus 1 is 4. So actually I could, because there's a 2 out the front, I could factorize the 2 from the bottom, and that would cancel the 2 out the front. So I've got 0 to 1 to t, so I've actually just got t squared minus 2t plus 2. Now we know that can be written, it's not very easily factorizable, but I can write it as I can complete the square on it, and then if you have a look, that's a nice integral. That just becomes, I'll do it over here, that becomes a nice inverse tan of t minus 1, and we're doing it between 0 and 1. So when I put 1 in, I get inverse tan of 0, minus when I put 0 in, I get inverse tan of negative 1. So we know that's 0 minus negative pi on 4, so that becomes plus pi on 4.